Hello everyone. Today we are going to discuss about the states of matter. In this states of matter, introduction class is over, and next we are going to dealing about gas laws. So in this gas laws, so we have to very much important one is Boyle's law. So what this Boyle's law is talking about? When you keep temperature at constant temperature, the pressure of the gas is inversely proportional to the volume. So what does it mean? As we increase the pressure of the gas, then what is going to happen? Volume of the gas is going to decreases. So as volume is increasing, that means pressure of the gas is going to decreases. That means the pressure and volume of the gas are inversely proportional. So this is what is going to give the relationship between pressure and volume by keeping temperature at constant. So this law is Boyle's law. So here at constant temperature, the pressure of the gas is inversely proportional to the volume of to the volume of gas to the volume of gas. What does it mean? So if let's take, if a gas is enclosed in a container, if a gas is enclosed in a container with frictionless piston, so this, when this gas is enclosed, what we are going to see, it will have some pressure P1 and it is occupying some volume V1. So this is what initial pressure and initial volume. So in this case, what you are going to see, so the pressure, how the pressure it is going to develop, since gas molecules, they are not stable. They are in continuous random motion. So in this random motion, what is going to happen? These gas molecules continuously strikes to the walls of the container. So they will collide with the walls of the container. So due to this collision, they are going to develop a pressure is called P1. So initial pressure, and they're occupying a space that is called volume. Hope you're clear. So in this point, what you have to understand, as the pressure is inversely proportional to volume, let's increase the pressure by compressing. Let's increase the pressure by compressing the piston towards downward. When you compress this gas, especially by pushing the piston downward, what is going to happen? The gas got compressed. Now the volume of the gas is getting decreased. Now volume become V2. Now new pressure is developed P2. So how we increase the pressure? By decreasing the volume. When you decrease the volume, pressure is going to increases. So how the pressure is going to be increasing? Because when you are pushing the piston downward, what is going to do? So that means we are doing work on the system. So when the work is done on the gas molecules, what is going to happen? Here there will be compression and here there will be increase in pressure. In further we are going to read about it. So this is what, as we increasing the pressure, the volume of the gas become decreased. So this is what the Boyle's law is talking about. And in this case, what we have understood, so this is talking about P is inversely proportional to volume. P is inversely proportional to volume by keeping temperature constant. Very much important. We have to keep the temperature constant. So in this, because of this reason, the pressure is inversely proportional to the volume. Let's take, so this is what the initial, what we can write here. We can write here, pressure is inversely proportional to volume. If you lift the proportionality symbol, what you're going to see here, we have to make it equal by taking out proportionality symbol. When you make it with equality, so we have to multiply constant. Let's take, this is constant is K, that is 1 by V. So this, both values are very much important. So in this case, what we can write, PV is equals to constant. PV is equals to constant. Let's take, if gas is changed from initial condition to final condition, like we can say initially the pressure is having P1 and volume is having V1. Pressure is having, finally due to compression, what happened? Pressure is increased to P2 and volume is decreased to V2. Now what is going to happen to their PV value? So in this case, when gas is changed from initial to initial final conditions, conditions. In this first case, what is the formula according to this? So P1 V1 is K. In the second condition, P2 V2 is equals to K. When the right sides are equal, then we can make it their left sides are equal. That means P1 V1 is equals to P2 V2. From this, what we understood, so in what ratio pressure is going to increase, in the same ratio volume is going to be decreased. So in this way, what we can write, this very much important formula regarding Boyle's law, that is P1 V1 is equals to P2 V2. And here pressure is inversely proportional to volume. That means pressure is equals to, what we can write here, when you lift the proportional symbol with equality, you have to multiply a constant, and PV is equals to K. So this is what about the concept related to Boyle's law. And now we are going to see graphical representation, which is highly important for NEET as well as JEE mains examinations. So what are the graphical representation? So in this graphical representation of this Boyle's law, what you are going to see, first one, if you draw a graph between pressure and volume, pressure and volume, as we have seen, pressure and volume are what, inversely proportional. When pressure and volume are inversely proportional, what kind of graph you are going to see? You are going to see decreasing graph, and it's going to be a curve. So it is what, this, you are going to see a curve, like where as pressure is increasing, volume is decreasing, as volume is increasing, pressure is going to decreases. So this is what pressure and volume graph. So if you see another graph which is drawn between, what is that, pressure and 1 by V, very much important, pressure and 1 by V. Since we know this 1 by V is single terminology, between pressure and volume there is inversely proportional relationship, but between pressure and 1 by V, you can see it is a directly proportional relationship between pressure and volume. So when there is a directly proportionality symbol or relationship, so what we can understand here, we are going to get a straight line graph. So the straight line graph, should it start from the origin or should it start from certain point in the y-axis? So from where the graph has to start, from where the straight line has to start, depending on y-intercept value. So how will you calculate y-intercept value here? If you can see, P is proportional to 1 by K. That means what we can write, P is equals to K into 1 by V. Since P is equals to K into 1 by V, so this equation, since it is directly proportional relationship, so we can equate it with straight line equation. So straight line equation is what? Y is equals to mx plus c. So on y-axis, what is there? Pressure. On y-axis, what is there? Pressure. On x-axis, what is there? 1 by V. So what is m here? M is the slope. M is the slope. So since m is the slope, that is k. M is the slope, that is k. That means some slope, straight line curve is a straight line graph is there. So in this case, what is the y-intercept? Y-intercept is 0. Y-intercept is 0 means the graph is going to start from, what is that? Actually, if y-intercept is some value is there, that means graph will start from certain point on the y-axis. But when y-intercept is 0, means the graph is going to start from the origin. So the straight line graph is going to be made from what? Straight from the origin. Are you clear? And next graph we are going to do, that is, let's take, if these graphs only made into different, we can write at different temperatures, at different temperatures. Let's see, if same graph is made at different temperatures, pressure and volume, so the graphs will be like this. So let's take, this is T1 temperature, this is T2 temperature, this is T3 temperature. And similarly, if the graph is made between pressure and volume, pressure and 1 by V, so these will be like at different temperatures, the slopes will be made in different points. So in this case, let's take, this is T1, this is T2, then this is T3. The next question comes, so which one has highest temperature? T1 or T2 or T3? So we have to understand it from the slope. That means K value, whose, what the slope is depending on. So on which factor? That means what is the nature of relationship between slope and temperature. So if between slope and temperature, if it is directly proportional relationship, then definitely higher the temperature, higher the slope. Now we are going to see what is the relationship. Let's take, we know that according to this equation, what is this? P, so this, for this graph I'm telling, P is equals to K into 1 by V. So P is equals to K into 1 by V. If this equation is equated with ideal gas equation, what is ideal gas equation? PV is equals to nRT. So what we can write? P is equals to nRT by V. nRT by V, what we can write in this way? nRT by V. As we know, this 1 by V, as we know, what is the relationship here? We got it here. So P is equals to nRT. This is 1 by V. So if you equate these two equations, from this what we understood, P 1 by V, 1 by V. This K value is equals to nRT. That means from this what we can write, K is equals to nRT. When K is equals to nRT, we know that N and R values are constant. So what we can write, K value is proportional to temperature. When K value is proportional to temperature, K means what is that? Slope. So slope is proportional to, directly proportional to temperature, means what we can understand, higher the slope, higher will be the temperature. So in this case, who is the higher slope? This is the higher slope. So this is the higher slope. So then definitely they will have more temperature because slope is directly proportional to temperature. So how we got to know that K is a slope? That means from this, when y is equals to mx plus c, so we got to know that m is what? Equals to K. That means y axis, what is there? Pressure is there. On axis, x axis, what is there? 1 by v is there. Y intercept is 0. So what is that? M is equals to K. So M means slope, that is equals to K. So higher the slope, higher will be the temperature. From this what we have understood, so T1 greater than T2 greater than T3 in this case as well. In this case also, T1 greater than T2 greater than T3. Similarly, we can draw one more graph belongs to this. So what is that graph? That graph is equals to PV graph and pressure. PV and pressure. As I told you in this Boyle's law, what happens? So as pressure increases, volume decreases. That means from this what we understood, that means in what ratio the pressure is going to increases, in the same ratio volume is going to be decreased. That means the PV value, if P is 2 bars and volume is going to become half. That means if pressure is doubled, volume becomes half. That means what is their multiplication? It will be 1. So how much pressure you increase, in the same ratio volume is going to be decreases. So because of that reason, PV value always remains constant. That's what we have seen, PV value remains constant. If you draw the graph with respect to pressure, if you draw the graph with respect to volume, so it will remain constant. And what is the graph it is going to become? It will be a straight line. If the same graph is done between PV and volume, so what is going to happen? Again, same thing. How much you increase the volume, in the same ratio, pressure is going to be decreased and their multiplication becomes a constant and you are going to get a straight line graph. So this is all about concept related to Boyle's law, and this is what graphical representation and what is the significance of Boyle's law in real life. As we know, the air near the sea level, the air which is present at sea level, it will be more dense because the air which is compressed actually near the sea level, the air is more compressed and it is more denser and having more pressure. So because of that reason, what is going to happen? As we move to higher altitudes, so in those higher altitudes, what is going to happen? Pressure is going to decreases. As pressure is going to decreases, what is going to happen? Volume is going to increases. That's why those, we can see, those are mountain climbers, they will always, mostly they are going to experience what is called altitude sickness. So because of that reason, because volume of air which is going to be expanded, as pressure is decreasing, as we are going to higher altitudes, volume is increasing. As volume is increasing, so that they are going to will have very less oxygen intake. So because of that reason, they are going to face altitude sickness, and this is one of the practical application. And next, another point also, when you see the balloons which are filled with hydrogen and helium gas, so when they are present near to the earth, what is going to happen? They will have less, we can say less expanded. As they're moving to higher atmospheres, the balloons are at higher atmosphere, you are going to see that means the balloons are going to be expanded. Why? Because as we are moving up, the pressure is going to decreases. When pressure decreases, the gas inside the balloon are going to be expanded. Hope you're getting my point. Pressure is less means volume is going to be more. That's why the gas balloons are going to be expanded. So this is what the physical significance of the Boyle's law. And always remember, during the examinations, they will ask you these kinds of graphs. In the case of NEETs or JEE, many previous year questions. So these kinds of graphs they're asking. So it's highly important to understand graphical representation. And also, if you want to solve the numericals, so this formula P1 V1 is equals to P2 V2. That means if they've given the gas is at certain pressure and the gas is at certain volume, but if you increase the pressure, what will happen? What will become the volume? So they will ask you these kinds of questions, and I will come up with the previous year questions as well as lots of questions for practice, especially for NEET as well as JEE regarding topic wise. Is it clear? And thank you for today's topic.